Good morning, everybody. Let's have a look at some of the questions that you actually answered so that you can see if you understood. The first question was looking back at, hey, what do you understand by a normal distribution? It's actually asking you to explain why would the volume of soft drinks in cans be normal distributed, diameter of bowls, all those type of things. The amount of toothpaste in a toothpaste tube. Now what happens? The company sets, say for a soft drink, 330 milliliters. So you might think that is actually the mean. The machine itself will of course not always give exactly 330 milliliters. It might give slightly less, it might give slightly more, depending on that particular moment. So you will have a bit of variation. Maybe it's sometimes 331, 335, 340, 330, 320, 325. So there will be a range of volumes in that can. Now, obviously that is symmetric. Sometimes it will give a bit more, sometimes it will give a bit less, but it's all around the mean that you have set. So it's normally, or it's normal distributed. The same about the diameter of bolts. And they will set a certain mean, and sometimes it's slightly more, slightly less, just because of the machinery that you're using, because it can't be 100% perfect. So there will be a standard deviation, there will be a variation around the mean itself. So we get here a normal distribution because it's symmetric to the left and to the right. Companies actually will use this, because if you say that your can has 330 milliliters, if you then get a can that only has 310 or 320, people might start to complain. So they won't set the machine at 330. They most likely will set the machine at 340. So that it is quite unlikely that you get something below the 330. Now that's one possibility they can do. What they also can try to do is to minimize the variation. Because the more times they're close to the mean, the less times you will have a can that actually has less than the 330 milliliters. So what was the whole answer? There is a mean, there's a slight variation because of the machinery you are using that will never be perfect, but it will be symmetric. So there will be a standard deviation and you have sometimes less, you have sometimes more. Normal distributed. So that was actually question 1. Let me go to question 2. See if I can find it. Oh, is my hand managing? Yes. There. Question number 2 was actually checking if you understood what my last lesson was all about. So they are asking about state the probability when you random select something and you have a normally distributed graph, what is the probability it lies below the mean, one standard deviation below the mean, up to one standard deviation above the mean. And the second part, the value, or what is the probability that you are above the mean and the value of 2 times the standard deviation. Now let's look back at our graphs that we were using. Here, I've used here different numbers. In this particular case, the mean is 184. That's this one here. If it would work, the mean is 184. So that's the one here. We know from my last lesson, on the left there is 50%, on the right there is 50%. They are now asking what percentage is between the mean minus the standard deviation and the mean plus the standard deviation. So in our case, the standard deviation that I used was 5. The mean is 184. So I'm looking at 179 up to 189. So they're asking you, what is the percentage here? What is the probability when you pick something at random that it's between that 179 and 189? From my lesson before, you should have picked up that that is always around the 68%. Let me see if I actually did shade that. No, I didn't. So let me shade that. From 179 to 189. Make it blue. So that part is always approximately 68%. It's slightly more in whatever normal distribution you have. So they were asking between the mean minus the standard deviation to the mean plus the standard deviation. So whatever you have, it doesn't matter, 68%. On the left side there, 34%. On the right side, 34%. Let me put that there. So your first answer here is mean minus standard deviation up to mean plus the standard deviation, 68%. The mean and the value 2 times the standard deviation above the mean. Let's go back to our graph. So what are they asking for? They are now asking 2 times the standard deviation. Now, the standard deviation is 5. 2 times 5 is 10. 184 plus 10, 194. That is this one here. Let's take away the other two. And all those numbers. So they're now asking, what is the area of this part? Let's again shade it. So it's between 184. Am I still there? Yeah. 184 up to 194. So that part. You know from the last lesson that between 2 times the standard deviation below and 2 times the standard deviation above, here from here, this whole part is 95%. Obviously the right side is half of that. So you will get 47.5. That was question number 2. Let's go back to the questions. We have done those two. Let me go to one more question. I set my graph up because of this 184 and this 5. And the mean is 184, standard deviation is 5. They are now asking taller than 189. Now 184 plus 5 is 189. So let's go back to the graph, telling me oh, that looks nice. I think that is the one. Eh? So we are looking at 189. Let's take away the other two. And let's take away the 95%. So what are they asking? They're asking you what is the percentage here on this particular part. So between 184 and 189. Now by now we know that 34%. Answer. And in between the standard deviation subtracted from the mean and added to the mean, it's 68. So your answer is 34. Taller than 179. 179 is 184 minus 5. So we are looking here at, where's my 179? This one here. Let's take away the 189. I think I might have shaded that. Let me have a look. Yes, it's this part. So they're asking more than 179. In between the two, we had 68%. So what is left for this particular part? 34. The left side is completely 50. It's 50. So what do we get? What is left for this part? 50 minus 34. So here, that is 16%. So 60% of all your values is on the left side of that 179. So what is there on the right side? 100 minus 16. And that gives you, think, 100 minus 16, 84%. So your second question here is 84%. Between 174 and 199. 199, did I do that one? I'm sure. Yes. No, yes, that should do it. Oh, here it's very small. See it? 199. There. Take away the shading. Let's take away the 68. Yeah, that's confusing me. Let's take away the mean. So they're now asking. No, that is not the one they are asking. Okay, let me shade it again. So they're asking between 179 and 199. Okay, so they are looking for that part. Now it looks a bit like the question from before. We know that here on the left side there's 16%. So this whole part is 84%. However, now they went to 3 times the standard deviation. So they actually looked at the mean plus 3 times the standard deviation. Now in my last lesson I didn't really talk much about that. But between 3 times the standard deviation subtracted from the mean and 3 times the standard deviation added to the mean, there's 99.7%. And that's the third figure. Meaning that is left 0.3%. And that 0.3% is the part here, this particular part. So above the 199 is 0.15%. That also would be below the, 169. So what's the part in between? 84 minus 0.15%. And that was question, over 199 centimeter. I already was saying to you, it's 0.15%. Now, all the other questions on that same page, they are more or less doing the same thing. They come back to this graph. They are coming back to look at the standard deviations, subtracted once, subtracted twice, subtracted 3 times, added once, added twice, added 3 times. We know the figures 34%, 34%. We know the figures 50 on both sides from the mean. We know the figures 13.5%, 13.5%. We know the figure 68. Where did the 68 go? Oh, there. And we know the figure 95. And I introduce now the one between, 3 times the standard deviation on the left and the right, 99.7. So every question in part 10a is just looking at this graph and asking you, okay, how much is this? I think I'm still missing one here. We had 2.5%. I hope you remember that. So with that, you should be able to finish the questions in 10a. Look back at it, because you will need this idea for the next part of this lesson.